are essentially copying you right now.
Yeah, I want you to just draw what I draw and pay attention. So I'm going to divide this page in half from top to bottom, just with a light line. Let's keep this all pretty light. And again, this is just reviewing kind of those 3 cube rules. I'm going to put a little circle and oval, and this is a really simple illustration looking down on a person who is then looking forward. So what we're going to talk about today are those 3 cube rules, and I'm just giving you a couple of demos. What I've realized, and I always forget this, is that sometimes it's hard to draw a cube at a 45-degree angle or a square. So we're going to draw a diamond. I want you to draw a diamond. I mean, each side maybe a little over an inch, about an inch. And it's difficult to evaluate this, but I just want you to sketch a diamond up here. And so what we're looking at right now is we are looking at a viewer that is looking straight ahead at a cube. The last thing I want you to do, let's just put a simple little picture plane in here. Let's label that. If you want to, you can label this as viewer. And I'm going to put a dot right here that represents the cyclops eye of this viewer. So what do we call it when our object is sitting at a 45-degree? Well, when our object is sitting right in front of us and it's sitting at a 45-degree angle like this. What is that? Well, no, because we're basically drawing, if you remember, any lines that are kind of going in this direction, these lines are going towards, if we will now from this point on draw a, I'm going to draw this again from the viewer's perspective over on this side of the page. Where are these lines going towards? Ultimately, when we draw this in perspective, those will be going towards the right vanishing point, and all the parallel lines this way are going towards the left vanishing point, or they will be. But one of the interesting things and what I want to point out here is just a couple of things. One is when our viewer sees this corner and this leading edge, they see about the same amount. Here's our picture plane. They're going to see the same amount of that right surface and the same amount of that left surface, right? This distance going through that picture plane is the same. Let's draw another cube over to the right of this one. About the same size. I'm going to try and get 3 over here. And this is where this gets interesting. Is now when I draw a line from my eyeball to this far right corner, to that leading edge, and the left corner, and I evaluate how much my person sees of each of those sides. They're going to see more of this left face of that cube than of the right face, correct? And again, one of the assumptions here, and which is an assumption that's not always true, is that each of these objects, each of these cubes, is sitting at a 45-degree angle relative to our viewer. And that's not always the case. It's just a way to think about this and help you set up perspective. Is that clear to everybody? We see more here than here. All right, so let's go over to the other page. I want you to do the same thing. Let's divide this in half. And now we're going to do a perspective drawing. What we were just looking at was what? Just a top view. And I'm going to put my training wheels on here. I'm going to put a left vanishing point and a right vanishing point. And then I'm also going to divide this. What's that line? What's that line that has the left and the right vanishing point on it? That's the horizon line. Whoops. And then this line that sits halfway between those two vanishing points. What is that? You know, I'm still waiting for Verizon to contact me and say you can't use that. And that's why I always say vertical horizon or Verizon, but we'll call it the Verizon line. And I'm going to draw this cube that's right in front of my viewer sitting at a 45-degree angle. But I don't know how high or low this cube is relative to my viewer. And I'm going to say for this one, let's draw that above the viewer. And so I'm going to put a leading edge up here. I'm going to make that cube about that tall. I'm even going to go through Verizon that I just drew. And I'm just going to draw that cube. And since it's above the horizon line, we're going to see what surfaces.
Sides in the bottom?
Yep, two sides on the bottom. So for each of those corners, I'm going to carry it over. Because this cube sits on the Verizon line, this is cube rule number 1. And again, this is if it's at 45-degree angles, and I'll talk about it in a minute. But let's evaluate the angles, that leading edge. If I evaluate these angles, what is the relationship of those two angles?
Should be the same.
They should be the same. If I've done this correctly, they should be the same. And that holds true for each of the angles that I create. It'll even hold true for this back angle back here if it's a cube, right? So remember that first exercise we did this summer, and I wanted you to ingrain the proportional relationship of the sides of a cube to that leading edge. I want you to draw a proportionally accurate cube. It almost, if it's sitting right there, it almost seems like it's a little too thin. The common mistake is to make this cube a little too wide. And I'm going to come back in. I should have been using construction lines this whole time. I'm going to darken in my object lines a little bit. Maybe a little less here on these front edges, thinking about 3 line weight, and maybe a little bit more back here to give it some heft, and maybe a little bit more on the right side, because I want us to start, and I think it's really kind of important sometimes, especially in these exploratory sketches, to help yourself and other viewers see the massing. Let's go ahead and put some hatching on these surfaces. So I'm going to hatch, and I'm putting about 1/8 of an inch in between each of these lines. I'm not putting a lot of pressure down. I'm just going to hatch that right surface. And I'm assuming that there is a light source, and this is just my default assumption, a light source coming in over my left, behind me, and over my left shoulder. And that means that my bottom surface is going to be a little bit darker, so I'm going a little less than 1/8 of an inch. I'm going to hatch that bottom surface. And I forgot to talk about the other cube rule. So, and by the way, I'm just sketching in color just for you to see. If you want to go with color, that's fine. But because this object, like in this example, is sitting right on that Verizon line and is at 45 degrees, I see an equal amount. I perceive the size of these two sides equally. And then the third rule, which we won't really see until we do another one, the third rule has to do with what? Do y'all remember? vertical lines? No, they're all the vertical lines are just going to be straight up and down and vertical. What's the third thing we want to think about?
Closer to the vanishing point. You see
That has to do with it. So things that are closer to a vanishing point, their lines converge faster, right? We're equal distance from both vanishing points. So the rate of convergence. And of course, when I'm sketching on, if I've got my training wheels, I don't have to really think about this because it's defined for me. I just have to draw my lines over to those. But my rate of convergence is the same on the left and the right. So this is the easy example, right? Now, there are problems. And in fact, I'll kind of share with you one of the challenges. There are problems when you draw something right on the vertical horizon. And if I was to draw this table, this little table right on the vertical horizon, what would happen to this leg right here? It would just disappear. I'd only see one edge. So it's typically good. It's usually good to draw something not sitting perfectly on the vertical horizon. So we want to talk about what it is that we really want to see. So let's draw a cube. Let's draw this cube, but let's draw this cube at eye level or right on the horizon line. I'm going to draw it about the same size. So that leading edge, a little bit more than an inch. And I'm going to go ahead, again, rule number 3 is kind of defined for me. My rate of convergence is easy to see because all I have to do is draw lines to the vanishing point, but we know that that's not always the case. So cube rule number 1. At least in this, today it's number 1. I'm looking at how much I'll see of each of those, right? So my viewers here, that is still sitting at a 45-degree angle relative to the picture plane. So I see more of the left surface than I see of the right. And in fact, it's pretty significant, right? At least from this distance. So I want to make sure that I see more of that left face and I see less of the right face. The angles aren't quite as easy to see right where it is, but if I had an object up here, it would be a little bit easier to see. But let's look at those angles and which one's shallower and which one's steeper, right? The closer it is to the vanishing point, you've got a steeper angle. The further away, you've got a shallower angle. So it's difficult kind of to see that, but does everybody see that? That's our other rule, right? And then the rate of convergence. If my object is to the right of the horizon line, the rate of convergence is quicker going towards the right and slower going towards the left. Simply because it has to get to that vanishing point quicker. And this has a longer way to go to get over to that vanishing point. Oh, let's go ahead and hatch in this right side. And then the opposite is going to be true over here. If we have a cube that is to the left of the horizon line, then I'll see more of the right surface, less of the left surface. So let's draw one more cube on this, and let's put it below the horizon line and over in this area. Again, about the same size. And the only real challenge, since we have our vanishing points on our page, my rate of convergence is equal, is defined for me. My angles are defined for me. But let's look at those angles real quick. Here I can kind of see a little bit, I can see it a little bit better than when it was real close to that horizon line. I've got a steeper angle going towards the left and a shallower angle, which that same thing holds true. Now they get shallower as we go towards the horizon line, but that same rule holds true for this cube sitting to the left. The challenge is figuring out how much of the surfaces of that cube I see. So should I see more of the left or the right side of this cube?
Right side.
And then, you know what? I'm gonna make a mistake on purpose because I want us to see it. So I'm gonna make a common mistake. So I'm gonna push that back there, and I almost see about, if we were to look at this distance, I'm still seeing more of the right side than I am of the left. But if I complete this cube, it should be fairly obvious. You guys should have trained your eye enough to recognize that what's wrong with that cube proportionally. It's too deep, right? It's too deep. And sometimes it takes kind of finishing the cube up for you to see that proportion correctly. And it's almost difficult for people when they first start sketching to pull this edge in a little bit too far, right? How many of you think you got this one right? You know what? When I look at mine, I think I need to add just a little bit there. So look at your neighbor and see if their proportion looks right. Oh, no. So I'm just going to hatch in one surface. And this is kind of a quick. So many of our objects that we draw, we draw below the horizon line. And if I'm doing exploratory sketches like this over here, I'll typically just pick one face and say, you know what, I'm gonna put some hatching on one face to help me out with the massing and help me visualize it. If you really wanted to, you could put a little bit less of a hatch right here, right, and just leave the top open, or you could assume that that's a lower light, and maybe the top surface would be a little bit darker. All right, just to complete this drawing and just reinforce again, some of these things I want you to think of this sketchbook as something you can go back to and reference. Where's our viewer? Our viewer, the eyeball's right there. Let's just put a simple, very simple little silhouette of a human being, and this is the one that I just like to draw. So it's an ellipse. It's like a 60-degree ellipse on its side. I'm drawing this in lightly, and then I put a slight angle. I put some shoulders in. We'll talk more about hands and human figure later in the semester. But this is my simple person. And then I'm just going to lightly hatch that. I'm putting a little less pressure down, almost like this person's invisible. So, just to kind of review real quickly. We've got 4 minutes. This is going to be tough. So, the three things you're looking at is you're looking at the angle, you're looking at the rate of convergence, and you're looking at the amount of each face that I see. And of course, not everything that we draw is a cube, but we use that cube unit, and we talked about this all summer, as maybe a way to set a foundation or begin a drawing. And if you understand those three things, then what you can do is you can say, you know what, I want to draw this object below the horizon line to the left of that horizon so that I see more of the right side, less of the left side. And that can be really important when establishing a perspective, because you might want to show off. If I want to draw this chair, I don't want to draw this chair from a 3/4 view looking at it from the front. I want to see more of the side because I think that's where the visual interest is. So I've got 3 minutes. I don't know what we're going to do.
I'm gonna draw a chair. I'll draw a chair in 3 minutes.
Draw a chair in 3 minutes.
I will if you want me to.
Yes.